Hello, Honor Statistics. We are starting Chapter 2, and we're going to be working with Section 2.1 first, dealing with frequency distributions, histograms, and topics related to those. So, ladies and gentlemen, that's the last thing we're doing in 2.1. So, reiterating, we did a frequency table that consisted of you finding a class width. There's a little formula, big minus small, divided by the class size, which I give you. Then you're going to find the class limits, the class boundaries, the frequencies, the relative frequencies, and the cumulative frequencies. You're going to learn how to draw a frequency histogram and a relative frequency histogram, and then you're going to finish off with an ogive, which is basically, or it comes from your cumulative frequencies. Okay, and that's the end of chapter 2.1. All right, you guys, this chapter is a little bit long, so in this 2.1, these are our key points. We are going to organize raw data using a frequency table. We'll show you how to construct a frequency table. We're going to construct a histogram, a relative frequency histogram, and an ogive. We're going to recognize basic distribution shapes: uniform, symmetric, skewed, and bimodal. And we're going to interpret graphs and contents of the data that we have. First, frequency tables. A frequency table partitions data into classes or intervals and shows how many data values are in each class. The classes or intervals are constructed so that each data value falls into exactly one class. And what we're going to do is we're going to construct this entire set of frequency table. What we need in it is we're going to be working with a class width. And the class width is going to kind of be given to you with a little bit of a formula. You're going to take the largest data piece. You're going to subtract the smallest data piece, and you're going to divide by a number that I'm going to give you. It's basically going to be the class size. So that's part of something I have to give you. So I'm going to say I want 6 classes, 7 classes, 8 classes. So we'll give you the denominator. So what are the things we're going to do? We are going to find our class limits. We are going to find our class boundaries. We're going to find the frequencies. We're going to find our relative frequency. And lastly, our cumulative frequency. So basically what we're going to get into is our class limits. Class limits are going to come from this guy here, starting with our smallest data piece and working with our class sizes. Class boundaries are going to be very important. Basically all you're going to do is you're going to subtract 0.5 and you're going to add 0.5. To the lowest, you're going to subtract 0.5. To the largest, you're going to add 0.5. And what that does, it sets up our histogram, and it sets up our x-axis, the boundaries on our x-axis. Frequency is very straightforward. You're going to count the number of data pieces that's within our class limit. So an example of a class limit, let's say the smallest data piece was 17. And let's say you go, the class size is 9. So you go 17, 18, 19, 20, 21, 22, 23, 24, 25. So it goes up to 25. That is 9 digits long. And then what you do is you go look at the data and define the frequency. You look at all the data pieces and you add them with your fingers and your toes that are between 17 and 25. Let's pretend there's 5 of them. You'd put a 5 here. Jumping back to class boundaries, if you start with a 17, the class boundary would be 16.5. Why? Because you subtracted 0.5. Since the largest is 25, you add it and you get 25.5. And you continue this process with all of these. The relative frequency is you take the total number of numbers, data pieces, let's say there's 38 of them, and you divide each of these numbers by 38. So 5 divided by 38, whatever the decimal is, we go to 3 decimal places. And finally, the cumulative frequency, we're going to go back to this 5, and whatever number is here, whatever number is here, we're going to continuously add them. So I'll fill a chart out for you guys completely. I just wanted to give you a basic of what we're going to do with a frequency table. Okay, so here we go. Example 1. A task force to encourage carpooling did a study of one-way commuting distances of workers in the downtown Dallas area. A random sample of 60 of these workers was taken. The commuting distance of the workers in the sample are given in our table. We're going to make a frequency table for this data. So remember, each of these are the number of miles, is it miles or the commuting distance that it takes to get to work, okay? So we're just going to kind of roll with this. Here we go. 1 and 8. Here's 1. Here's 2. Here's 3. Here's 4. Here's 5. Here's 6. Here's 7. Here's 8. Here's 9. Here's 10. 11. 12. 13. Looking. 13. 14. All right, so I am going to tell you how many classes. In this case, we want to use 6 classes. They're going to tell you that. Actually count them. So how do we compute it? Like I said earlier, we're going to take our largest data piece, take away the smallest data piece, and divide by the desired number of classes. And here's the biggest one. You must always increase the computed value to the next highest whole number. So if it comes out to be 4.1, you got to go to 5. If it comes out to be 4.9, you go to 5. Okay? If it's 13.00001, you go to 14. You have to go to the next whole number. And so in this example, I could go back to the data, but 47 miles was the largest one. 1 was the smallest in those 60 data pieces that we had a little earlier. We divide by the 6, which was given to you, and that equals approximately 7.7, which we increased to 8. Therefore, our class width is 8. Okay, so let's see what that does. 8. See how many. And counted. I'd rather just fill up. Okay, so let's look at this guy real quick. Your class limits always starts with the first data piece, 1. All right, remember we knew that because remember it was 47 minus 1. So 1 is your first data piece. Your class limit that you found was 8. That doesn't mean where this 8 comes from. If you start with 1 and count 1 using your finger, 1, 2, 3, 4, 5, 6, 7, 8, that's where it ends up. That's where we got, that's how you use your class width. Well, if you ended with 8, where's my eraser? There we go. If you ended with 8, then guess what? You pick back up at 9. Right? Adding to that, you end up with 16. Pick back up at 17. Go to 24. Pick up at 25. Go to 32. There's 8 numbers between 25 and 32. Pick up at 33. There's 8 numbers from 33 to 40. Pick up at 41. There's 8 numbers to 48. So what will happen is when you're done, your largest data piece must be within this last class limit. Your class boundaries, everyone, like I said, please subtract 0.5 and add 0.5 respectively to each one of these numbers. Now let's do our frequency. Midpoint we don't do, okay? They don't have us doing any, there are things called polygons and they're not doing them, so we don't worry about them. So what do they do? Everyone, let me go back to the data real quick, and we're gonna look for numbers between 1, they did a tally, look here, and they got 14. So ladies and gentlemen, that's how a frequency works. You just walk through and count all the numbers within that limit, okay? Oopsie, where's my eraser? What am I erasing this stuff here? Okay, so let's talk about here. 9 through 16, there were 21. 17 to 24, there was 11 data pieces. Between 25 and 32, there was 6 data pieces. Between 33 and 40, there were 4 data pieces. And between 41 and 48, there were 4 data pieces. So I told you the next thing is our relative frequency. And the last thing is our cumulative frequency. Let's do cumulative real quick because it's easy. All we're going to do is we're going to start with this first number, 14, and then you're going to add 21 to it. So that gives us what? 35. And then you're going to add 11 to that, and you'll get 46. And then you add 6 to that, and you get 52. And then you add 4 to that, and you get 56. And you add 4 to that, and you get 60. And remember how many data pieces there were? There were 60 data pieces. That's how many data pieces they found in that original chart. So this number will end up with a total number of data pieces. And now relative frequency. What we're going to do is we're going to take this 14 and we're going to divide it by the total number 60. So 14 divided by 60 is 0.233. I'm going to ask you to go to 3 decimal places. Then you're going to take 21 and you're going to divide it by 60, and that gives you 0.35. It terminates, so 2 decimal places. 11 divided by 60 is 0.18333, so 0.183. 6 divided by 60 is 0.1. 4 divided by 60 is 0.06666, so 0.067. And this is 0.067. Ladies and gentlemen, these numbers will add up to give you 1, or a number really, really close to 1, like 0.999, which is it's okay, or 1.001. Either one is acceptable because there was a little bit of rounding. So what you see right now is everything that I'm going to ask you for in a frequency table. Class limits, class boundaries, frequency, relative frequency, and cumulative frequency. And that'll finish it up with the frequency table. Now we roll right into histograms and relative frequency histograms. Okay, remember histograms are bar charts, but they actually touch each other. Okay, so there's our same data. That's our chart that we worked with. Class boundaries. So remember I told you to add the 0.5 and subtract the 0.5. These are going to be your x-axis values. 48.5. Okay, they overlap. 8.5, 8.5, 16.5, 16 point in the boundary. Whoops. There's our frequencies and relative frequencies. Back just to show you, our frequencies start with 14 and then goes to 21, 11, 6, 4, and 4. So 21 is our largest data piece. Are your X5 should overlap frequency. There's 14. So what we're going to go back, and the next guy's 21. You look at your next number is 11, and then you have a 6. Axes are going to deal with our frequencies. So we look at our largest frequency, which is 0.35. Make sure. So 0.23, 0.35 is 0.18. Next one right here is 0.10. All right. So I jump back here because I wanted to show you, remember, we're working on an ogive right now. So an ogive comes from your cumulative frequency. I jump back here to this previous example because I just wanted to show you. So just to make sure you know, copy them here, 0.5, 8.5, 16.5, and so on. And notice I did our cumulative frequencies. So if there are 60 data pieces, the first thing you're going to have to do is you're going to have to say, this is going to go up to 60. And we'll go 50, 40, 30, 20, and 10. So it's my job to figure out the scale of the y-axis. These are all obviously your cumulative frequencies because you want to label each axis. All right, and here we go. Notice there's no data pieces below 1. That's why the ogive must start at 0. So ladies and gentlemen, whatever that first class boundary is, in this case 0.5, the ogive starts there. And then everyone, we're going to go up to 14 at the 8.5, so 14 is about right here. And then at the 16.5, we're going to go up to 35. So here's 30, 1, 2, 3, 4, 5. It's about right here. Just so you know, I'm looking across here. That's about 35. And then at the 24, we're going to go up to 46. So the 24, we're going to go up this way, just so you know where I'm going and what I'm doing, to about 46. And then we're going to go up to 52. And we're going to go up to 54. And finally, at the 48.5, we're going to go up to 60. And then we're going to connect the dots. Ladies and gentlemen, that is an ogive. An ogive comes from your cumulative frequencies. You must start at 0, and then at each other class boundary, you're going to put a dot for each of the frequencies, cumulative frequencies. Okay? And let's take a look at what each of these look like. So, our frequencies, therefore, they decided to make our histogram go to 24. Why? Because they went in sixes. 6, 12, 18, 24. Okay? So as long as you're going within the realm of the problem, you are going to be fine. Okay? If you wanted to go 5, 10, 15, 20, 25, it would work the same way. So it's your job to do the y-axis. That's your frequency, okay? Notice this 0.5, 8.5, 16.5, 24.5. Notice where those come from, okay? The axis values. Notice the last guy is 48. Why? Because these histograms, they come up right next to each other, okay? And then everybody, we look at each piece. So this is our is we're going to say, okay, this is 12, so 14 is about this high, and you're going to draw a building 14 units high. So you come over here and you figure out about where 21 is, and you draw a building right next to your first building, and this is 21 units high. That's your frequency. So therefore, if that's 12, so this is about 11, so you draw a building. 4 and a 4. A 6, a 4, and a 4. Ladies and gentlemen, you are looking at a frequency histogram. Now, if you look next to it, this is a relative frequency histogram. Do you see the x-axes are all the same, but notice the y-axes are different. And we're going to set this up with 0.4, 0.3, 0.2, and 0.1. So the y-axis is kind of up in the air on how you want to do it. You look at the largest data piece, the largest percentage, and you make your y-axis accordingly. So according to this is about, look, here's 0.2. So this right here is 0.23. And then this one right here is the 0.35. This building here, my history, 0.18. This building here is 0.10, and then the 0.07, and 0.07 respectively. Ladies and gentlemen, this guy right here is called a relative frequency histogram. And if you get back and look at it very carefully, they should look exactly the same. The only thing different, and I'll do this in green, is the y-axis. These are your frequencies, and these are your percentages or relative frequencies. It's the same. Remember all of these x-axis data pieces right here? Notice something very straightforward are your distribution shapes. So when you draw a histogram, you have a mound shape, which is symmetrical. I like the word symmetrical better. You have uniform, you have skewed left or skewed right, and bimodal, I don't really like it very much. We're not going to talk. But if you look at it, this guy right here is considered to be symmetrical. Symmetrical means it has the same number of buildings on either side. The middle's tall, and then it gets lower and lower, and then lower and lower, and then lower and lower. This is uniform. Look, very plain to see. Every building is the same height. Now, skewedness. Do you notice the more little buildings this way? And this has more this way. So it goes tall and down, tall and down. The skewness is towards what we call the tail. The tail is where the smaller pieces are. So this is an example of skewed left because this is on the left. This is skewed right because it's getting smaller towards the right. So let me just draw real quick. If I go big building and then little smaller, little bit smaller, 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 smaller. Ladies and gentlemen, this is skewed towards the right, okay? So it's where the little buildings are is where the skewness. And I know I wasn't going to talk about bimodal, but notice that there's two big buildings here, and that's why it's called bimodal. But we're going to concentrate on these four, which is symmetrical, uniform, skew left, and skew right. And finally, a cumulative frequency table is called an ogive, okay? Ogive. The cumulative frequency, if we go back, I think we should have the cumulative they did a whole nother example for us, okay? So let me go back here real quick. Let me pause.